Okay, so let me do section 3.2, graphing linear equations in two variables. So first off, let me tell you about intercepts. So suppose I have some curve in the plane relative to some coordinate axes. So if I look here, where I intersect the y-axis, these are called y-intercepts. So these points here are called y-intercepts. And let's look where this curve intersects the x-axis. Those are called x-intercepts. Because they intersect the x-axis. And so these are your x-intercepts. X-intercepts are also sometimes called roots. If I'm talking about some polynomial. And they're also called the zeros of your function. So if you're talking about a function, then these are actually called zeros. If you're talking about a polynomial, then these are called the roots of a polynomial. But they're all the same thing. So to find an x-intercept, you set y equal to 0, and then you solve the resulting equation for x to find the y-intercept, which of course means that for any x-intercept, the y-coordinate will be 0. So to find the y-intercept, we set x equal to 0, then we solve for y. So again, for a y-intercept, the x-coordinate is always going to be 0. Okay, so let's do some examples. Let's say on page 111, let me do problem number 1. In exercises 1 through 20, complete the table of x values and y values. For the given equation, draw the graph of the equation by plotting these points. So I have here x, y, 0 to 5. The equation is x is equal to 3. Therefore, each of these x coordinates are 3. So let's draw the graph of this. Actually, let me go down a little further. So let me place all my tick marks. So x is 3, y is 0. X is 3, y is 2. X is 3, y is 5. And so if I draw a line passing through these 3 points, I have the graph of x equaling 3, which recall is a vertical line. Let me do problem number 3. So in this case, I have -4, 0, 2, and I have y is equal to 5. Therefore, all the y coordinates are 5. And so let's sketch the graph of this. Okay, so at -4, y is 5. At 0, y is 5. At 2, y is 5. And so this is the graph of the line y equals 5. This is called a horizontal line. Let me do problem number 5. So we have -3, 1, 3. And we have 5. Actually, I'm not doing 5. So we have 3, -1, 4. The equation is x plus 2 equaling 0. Subtracting 2 from both sides of my equation, I have that x is always equal to -2. And so x is always equal to -2. Let's try to sketch the graph of this. Supposed to be -2. Oh, I see. That was fine. That was fine. Okay, so -2, 3, -2, -1, -2, 4. So draw a line passing through those points. Okay, good enough. Okay, and so I have, again, this is the sketch of the graph, x plus 2 equals 0. So again, this is a vertical line. Let me do problem number 7. So I have here 7 xy. So I have -3. I'll have more room. 1, 3. 2y plus 6 equaling 0. Subtract 6 from both sides of your equation. Divide by 2. So in this case, y is always equal to -3. So no matter what x is, y is always -3. Let's sketch the graph of this. Okay, so when x is -3, y is -3. When x is 1, y is -3. When x is 3, y is -3. So let's draw the line through these points. So this is the graph of 2y plus 6 equaling 0. Again, this is a horizontal line. Let me do problem 9. Okay, so I have x is 3, -3, 0. And I want to sketch the graph of y equaling -2/3 x plus 3. Let me solve for x. So let me multiply both sides of my equation by 3. So I get 3y is equal to -2x, the 3's cancel, plus 9. Subtract 9 from both sides of my equation. So by the added property of equality, I get that 3y minus 1 is equal to 2x. Divide both sides of the equation by 2. And so I get that x is equal to 3y divided by 2. Why am I solving for x? Okay. I'm plugging in x. Okay, so let's see what happens when x equals 3. Well then, I get y is equal to negative 2/3 times 3 plus 3. The 3's cancel. And so I get negative 2 plus 3, which is just 1. Okay. Let me plug in when x is equal to negative 3. Let's determine y. So y is equal to negative 2/3 times negative 3. The negative 3's will cancel. So I just get that y is equal to 2 plus 3, which is 5. And so this is 5. And lastly, let's see what happens when x is 0. Well, when x equals 0, I have y equals negative 2/3 times 0 plus 3. Well, negative 2/3 times 0 is 0, plus 3 is just 3. And so I lastly have 0, 3. Let's try to sketch the graph. Oops. So let me sketch the graph here. Place the tick marks as evenly spaced as possible. Okay, so let's see. We have here 3, 1, negative 3, 5, mm, 0, 3. Okay, so let's try to draw a line through those, if possible. And so I have the following is the sketch of the graph. Y equals negative 2/3 x plus 3. Okay. Let's do problem number 11. Y equals. And so I have here 360. And the equation is y equals negative 2/3 x minus 2. So when x is equal to 3, I have y equals negative 2/3 times 3 minus 2, which is a negative 2 minus 2, negative 4 for y. Let me determine when x equals 6. I have y is equal to negative 2/3 times 6 minus 2. 6 divided by 3 is 2, times negative 2 is negative 4. Minus 2 is a negative 6. And when x equals 0, I have y equals negative 2/3 times 0 minus 2. Well, negative 2/3 times 0 is 0, minus 2 is negative 2. And so I have negative 2. Let's sketch the graph of this. Okay, let's sketch the graph. Try to make the line a little straighter. Okay, so when x is 3, y is negative 4. When x is 6, y is negative 6. When x is 0, y is negative 2. So let's try to sketch the graph of this. Okay, so I have so make the points a little bit. Well, that one's obviously far off. Okay, so I have that this is the sketch of the graph. Y equals negative 2/3 x minus 2. Let me do problem number 13. So I have negative 3, 1, 3. I have 2x plus y equals 0. Let me subtract 2x from both sides. So y equals negative 2x. Let me determine its value when x is negative 3. So I have y equals negative 2 times negative 3, 6. Let's see what happens when x is 1. Y is equal to negative 2 times 1, negative 2. And what happens when x is 3? Y is equal to negative 2 times 3, negative 6. So let's sketch the graph. Get the right color. Okay, so do this. It's kind of hard to fit everything on there. 1, 2, 3, 6, 7. Good. 1, 2. Good. So when x is negative 3, y is equal to positive 6. When x is 1, y is negative 2. When x is 3, y is negative 6. And so, this is a long way away. Let's see if I can sketch the graph. Okay. Let's try that again. Okay, let's try this again. See if I can do it. Okay, it looks better. Okay, so this is the sketch of the graph. 2x actually goes to the origin, but 2x plus y equals 0. Okay. It's a little bit off, but not too bad. Okay, let me do problem number 15. So 15, I have 0, 5, negative 5. I want to sketch the graph of 3y, 3x equals 5y. So let's divide both sides of my equation by 5. So I get y equals 3/5 x. Let me determine y when x is 0. So y equals 3/5 times 0, which is 0. Determine y when x is 5. The 5's cancel. So y is 3. Determine y when x is negative 5. Positive times negative is negative. The 5's cancel. So y is negative 3. Okay, so let's sketch a graph of this. Let's see if I have enough room. 2, 4, 5. Okay. 1, 2, 3, 4, 5. Okay. 1, 2, 4, 5. Good. 1, 2. Ooh, just made it. Okay. So when x is 0, y is 0. When x is 5, 5, 1, 2, 3, 4, y is 3. When x is 1, 2, 3, 4, 5, y is negative 3. Let's try to sketch the graph of this. So this is the graph of 3x equaling 5y. Let me do problem number 17. So the equation is 2x plus 3y equaling 2. I have the following points. This is 17. 2, 4, 0. Okay, so let's complete the table of values. So I have here when when y equals 2, I have 2x plus 3 times 2 equals 2. 3 times 2 is 6. Subtract 6 from both sides of your equation. So 2y equals negative 4. 2x equals negative 4. Divide both sides of your equation by 2. So x equals negative 2. Substitute y equaling 4. X equaling 4. And so I have 2 times 4 plus 3y equals 2. 2 times 4 is 8. Subtract 8 from both sides of your equation. So 3y equals negative 6. Divide both sides of the equation by 3. So y equals negative 2. Lastly, I have when y is 0. When y is 0, when y is 0. 3 times 0 is 0, plus 2x is 2x. Divide both sides of the equation by 2. So x equals 1. So let's try to sketch a graph of this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so at negative 2, we're at positive 2. At 4, we're at negative 2. At 1, we're at 0. So let's sketch the graph. Oops. Hopefully, let's see. Can you see what I'm graphing right now? Or did it blank out? It may have blanked out. Okay, let's see. No. Okay. So, sorry about that. Oh, I know. I've got to do this first. Okay, so we have here, this is a sketch of the graph, 2x plus 3y equals 2. Okay, so everyone can see this now, right? Yes, okay, good. Okay, so that's a sketch of the graph, 2x plus 3y equals 2. Let me do problem 19. Okay, so for 19, I have the following. Negative 1, 3, negative 5. And start up here. Okay, so, and I have 19. 3x equals 1 plus 4y. So let's see what happens when y equals negative 1. I have 3x is equal to 1 plus 4 times negative 1. So 3x is equal to 1 minus 4. So 3x equals negative 3. Divide both sides of the equation by 3. So x equals negative 1. Okay, good. Oh, negative 1, negative 1. Okay. Let's see what happens when x equals 3. Okay. I have 3x is equal to 1 plus 4y. And so I have 9 is equal to 1 plus 4y. Subtract 1 from both sides of the equation. So I get 8 is equal to 4y. Divide both sides of the equation by 4. And so y is equal to 2. Lastly, let's see what happens when x equals negative 5. I have 3 times x equals 1 plus 4y. 3 times 5 is 15. Subtract 1 from both sides of your equation. So 4y equals negative 16. Divide both sides of the equation by 4. So y is equal to negative 4. Okay. Let's sketch this. I won't be able to go that far. Oh boy, that's not straight. Okay. Place tick marks. Okay, so let's see. When x is negative 1, y is negative 1. When x is 3, y is 2. When x is negative 5, y is negative 4. Let's sketch a graph of this. So this is a sketch of the graph. 3x is equal to 1 plus 4y. Let me do problem 21. Problem 21, 3x plus 5y equals 15. In exercises 21 through 36, find the intercepts for each equation. So let's find the x-intercept first. You find the x-intercept by setting y to 0 and solving for x. 5 times 0 is 0. 3x plus 0 is 3x. Divide both sides of your equation by 3. And so x is equal to 5. Therefore, the x-intercept is at the point 5, 0. Let's find the y-intercept. You find the y-intercept by setting x equal to 0 and solving the resulting equation for y. 3 times 0 is 0 plus 5y is 5y. Divide both sides of your equation by 5. And so we get that y is equal to 3. So the y-intercept is at 0, 3. So I have one x, one y-intercept. Let me do problem number 23. Negative 4x plus 3y equals 12. Okay. Okay, so let's Yeah, so being consistent, yes. So yeah, every time we want to find the intercept, we set the other variable to 0 and solve for the unknown. So to find the x-intercept, set y to 0, solve for x. To find the y-intercept, set x to 0, solve for y. Okay. Okay, let me do problem 23. So let's find the x-intercept. Set y to 0, solve for x. 3 times 0 is 0. Negative 4x plus 0 is negative 4x. Divide both sides of your equation by negative 4. So x equals negative 3. So the x-intercept is at the point negative 3, 0. Let me find the y-intercept. To find the y-intercept, set x to 0, solve for y. Negative 4 times 0 is 0, plus 3y is 3y. Divide both sides of my equation by 3. So y is equal to 4. So my y-intercept is at the point 0, 4. Okay. Let me do problem number 25. X minus 7y is equal to 3. Let's find the x-intercept. Set y to 0. 7 times 0 is 0. X minus 0 is x. So x is equal to 3. So the x-intercept is at the point 3, 0. Let's figure out the y-intercept. Set x to 0 and solve for y. Okay, so 0 minus 7y is negative 7y. Divide both sides of the equation by negative 7. So y is equal to negative 3/7. And so my y-intercept is at 0, negative 3/7. Then we do problem number 27. For x minus y equals 0. Let's find the x-intercept. Set y to 0. Solve for x. 4x minus 0 is just 4x. Divide both sides of the equation by 4. So x is equal to 0. So the x-intercept is at the origin. Let's find the y-intercept. And so I have, so I set x equal to 0, solve for y. 4 times 0 is 0 minus y is negative y equals 0. Divide by negative 1. So y equals 0. So the x and y intercepts are just at the origin. So this curve happens to pass through the origin. Let me do problem number 29. Two, 2x plus 3 equals 0. So let's find the x-intercept. Set y equal to 0, solve for x. You can't. There's no y. So in this case, there's no solution to that equation, because I didn't even have the equation. So there's no x-intercept. Let me find the y-intercept. Set y to 0, solve for x. Set x to 0. Why am I so stupid? I'll have to get back to the x-intercept. Set x to 0, solve for y. So 2 times 0 is 0. 0 plus 3 is equal to 3. But that's a contradiction. So there is no y-intercept. Set y to 0. Done. Solve for x. Subtract 3 from both sides of your equation. So 2x equals negative 3. Divide both sides of your equation by 2. So x equals negative 3 halves. And so that says that my x-intercept is at the point negative 3 halves, 0. Sorry about that. Okay. Let me do problem number 31. Yeah, so there's no y-intercept, but there is an x-intercept. This is a vertical line, so it has an x-intercept, but no y-intercept. Okay, 31, 3y equaling 5. So to find the x-intercept, you set y equal to 0, solve for x. But 0 equaling 5 is impossible. So there is no x-intercept. This is actually a horizontal line. So it's parallel to the x-axis. Yes, it is a horizontal line. Okay. So let me do, let's find the y-intercept. Set x equal to 0. and solve for y. Divide both sides of the equation by 3. So y equals 5/3. So the y-intercept is at the point 0, 5/3. And that is your answer. Let me do problem number 33. Y equals 1/3 x plus 2. So let's find the x-intercept. So let's set y equal to 0. Solve for x. Subtract 2 from both sides of my equation. Multiply both sides of my equation by 3 to get rid of the denominators. So x is -6. And so the x-intercept is at -6, 0. Let me find the y-intercept. To find the y-intercept, you just set x equal to 0. Solve for y. So y is equal to 2. Therefore, the y-intercept is at 0, 2. Okay. Let me do problem number 35. Y equals 2/5 x plus 1. So let's find the x-intercept. Set y equal to 0. Solve for x. Multiply both sides of the equation by 5. So I get 0 equals, the 5's cancel, 2x plus 5 times 1 is 5. Subtract 5 from both sides of your equation. And so I get that 2x is equal to -5. Divide both sides of the equation by 2. So x equals -5/2. So the x-intercept is at -5/2, 0. Let's find the y-intercept. Set x equal to 0. And solve for y. 2/5 times 0 is 0, plus 1 is 1. And so that says that 0, 1 is your y-intercept. Okay. Let me do problem 37. In exercises 37 through 60, graph the linear equation. Use intercept whenever convenient. Okay, so I want to sketch the graph of x plus 2y equals 4. So let's complete a table of values. Oh, 33 again. Sure. So I want to find the x-intercept. You just set y equal to 0 and solve for x. So I can subtract 2 from both sides, then multiply by 3 to get rid of the fraction. Or I could have actually multiplied by 3 first and then subtracted the 6 from both sides. But in either case, you get x equals 6, negative 6. To find the y-intercept, you set x equal to 0. So 1/3 times 0 plus 2. 0 plus 2 is 2, so y equals 2. So that's your other, the y-intercept. Any questions about that? Okay. Let me do, 37. Okay, so in this case, they don't tell you what points to pick. They did that in the previous ones, nor if it should be x's and y's. I guess I'll pick some relatively nice y values. Okay, so I get, and actually what I'll do here is let's solve for x. So let me subtract 2y from both sides of my equation. So I get x equals 4 minus 2y. So to figure out what happens when when y equals negative 1, I have x is equal to 4 minus 2 times negative 1. Negative times negative is positive. 4 plus 2 is 6. So we have here 6. Let's plug in y equals 0. So x is equal to 4 minus 2 times 0. 2 times 0 is 0. 4 minus 0 is 4. So x is 4. Let's determine what happens when y is 1. So x is equal to 4 minus 2 times 1. 2 times 1 is 2, so 4 minus 2 is 2. So x is 2. Okay, let's sketch the graph of this. Let's sketch the graph of this. I go all the way to 6. Okay. And 1 and negative 1. Okay. Okay. So I have when x is 6, 1, 2, 3, 1, 2, 3. Y is, oops, negative 1. When x is 4, y is 0. When x is 2, y is 1. So let's sketch a graph through those 3 points. So this is the sketch of the graph. X plus 2y equals 0. Is x plus 2y equals 4. Let me do problem number 39. Two x minus 3y equals 0. Let's complete the following table of values. Let's put in 0, -2, and +2. I'm sorry, -3 and +3. So let's plug in those values. Okay. Matter of fact, I guess what I'll do is rewrite this. And so I have subtract 2x from both sides of the equation. Divide each term by -3. So I have that y is equal to negative divided by negative is positive. So 2/3 x. Positive divided by negative is negative. 6 divided by 3 is 2. Okay, so suppose that x equals -3. Then I'll replace x by -3. The 3's cancel. Positive times negative is negative. -2 minus 2 is a -4. Let's plug in, determine the actually will be an intercept. So substituting for x equals 0, I get y equals 2/3 times 0 minus 2. 2/3 times 0 is 0 minus 2 is -2. Lastly, let's see what happens when x equals +3. So y equals 2/3 times 3, which is +2, minus 2, which is 0. So actually I drew two of the intercepts, or both of the intercepts, maybe I should say better. So when, let's put in a tick marks. Tick marks are actually like the hardest things to put in correctly. Okay, so let's see. When x is -3, y is -4. When x is 0, y is -2. When x is 3, y is 0. Okay, so let's try to sketch this. Okay, so this is the graph of two x minus 3y equaling 6. And we do 41. Two x plus 3y equals 5. So let's pick some values here. So negative 2, 1, and 3. So that'd be 4. Okay, so let's try to determine the corresponding values. So let's see what happens when x equals negative 2. You guess which ones work. So I'll tell you the technique I used. What I did is I saw there was an easy solution. So, so that's the question is, and that's actually the hardest question is, what values to choose. So the first thing I notice is that 1, 1 is a solution. Okay, so I notice that 1, 1 is a solution. Okay, so that's really where I start off at. Then I can either pick x's or y's. It really doesn't matter which one I do. I chose x, and so I look at the number in front of x, 3. And that's what I add and subtract to the x-coordinate of the y, the x-coordinate of the 1. So 1 minus 3 is negative 2, 1 plus 3 is 4. Or I could have done the following. Add those to x. Or I could have looked at the number in front of x, which is 2, in which case I would have added those, subtract the 2 to the x. Okay, so I would have gotten, if I would have added 2, I would have got a 3, subtracted 2, added 2, got a 3, subtracted 2, a negative 1. Okay? And that would have been, so either you can add 3 to the x, subtract 3 from the x, or do it where you add and subtract 1. Actually, notice I have the 3 points. That should work. Okay. So either way of doing that should work. Yeah, but how do you figure out the numbers? Right? So the question is, how do you know what numbers to plug in? That's the hard part. So unfortunately, with this technique, it doesn't tell you what numbers to plug in. And so that's really sort of the hard part here. Okay, so let's do this. So you get a 1 here. So I should add 3. So that gives you a 4. And subtract 3. That gives you a -2. Okay, so let's see what happens. What happens when x equals -2? So you get 2 times -2 plus 3y equals 5. So you get a -4 plus 3y equals 5. Add 4. So 3y equals 9. Divide by 3. So y equals 3. Plug in for 1. So you get 2 times 1 plus 3y is 5. 2 times 1 is 2. Subtract 2 from both sides of your equation. And so you get that 3y equals 3. Divide both sides of your equation by 3. And so you get that y equals 1. Now, what you'll notice is on the computer, when you do these problems, all of your answers must be integer valued. So you have to find 3 different points where each of the numbers in the ordered pairs are integer valued. So that makes it difficult. So that's why well, this is the technique I use. And then lastly, let's figure out what happens when x is 4. Oops. So I get 2 times 4 plus 3y equals 5. 2 times 4 is 8. Subtract 8 from both sides of my equation. So 3y equals -3. Divide both sides of my equation by 3. So y equals -1. Okay? And so then I got to sketch the graph. So let's sketch the graph. I guess there's not much else to do. Okay, so you have to do it on another page. Place our check marks on. Okay, so I'm here at, oh boy, -2, 3, 1, 1. -2, 3. -2, 3, 1, 1. And lastly, 4, -1. Okay, and notice they all nicely go through integer values. And that is the sketch of, what problem are we doing? 41. Oops, so this is the graph of 2x plus 3y equals 5. Okay. Let me do problem number 43. 43 is actually easier. I have x equals 3y plus 2. So in this case, let y equal negative 1, 0, 1. And then determine what x is. Okay, so when y is 0, negative 1, so when y equals negative 1, I have here x is equal to 3 times negative 1 plus 2. Negative 3 plus 2 is negative 1. When y equals 0, I have x is equal to 3 times 0 plus 2. But 3 times 0 is 0 plus 2 is 2. Yeah, no, I'm just choosing. So no, they weren't given. So the points, none of the points were given. However, in this case, I noticed that x is equal to something. And so I could just pick nice y values. So I picked some nice y values to plug in to the equation. So lastly, let's see what happens when y is 1. So when y is 1, I have x equals 3 times y plus 2. 3 plus 2 is 5. So let's sketch this. Put the tick marks. Okay, so at negative 1, we're at negative 1. At 2, we're at 0. At 5, 1, 2, 3, 4, 5, we're at 1. And so, it should look like good enough. I sort of missed them all. And that's okay, let's see if I can get them. Okay, it's not as easy as one thinks. Okay, that's good enough. Again, I'm off by, I think it's the same, I was off the same as I was before. Okay, so I'm sketching the graph x equals 3y plus 2. Let me do problem number 45. Oh, what time does it end? Um, let's see. I have 10 more problems, which should go. I'd say about 14 more minutes. So I should be able to get done. I think with those last few, so that I've done them all. Okay, so 45, x equals -3. So it doesn't really matter what you pick. For y, because x is always equal to -3. And so I have the following. At -3, we're at -1, at 0, and at 1. So if you sketch the line going through these points, we have a nice vertical line. So this is the graph of x equaling -3. Let me do 47. Y plus 1 is 0. Subtract 1 from both sides. So y is equal to -1. Therefore, it's easy to pick. It doesn't really matter what you pick for your x values, because for any x value, y is -1. So let's sketch the graph. So at -1, we're at -1. At 0, we're at -1. At 1, we're at -1. So it's always just this line. So this is the graph of y plus 1 equaling 0. (49) x plus y plus 4 equals 0. Let me subtract x 4 from both sides of my equation. So I have here y equals -x minus 4. So let's pick some values. Let's say -3. Let's go for -4. -3, -2. Okay. And so x equaling -4 says that y is equal to -4 minus 4. 4 minus 4 is 0. Let x equal -3. And so y is equal to minus a negative 3 minus 4. So 3 minus 4 is negative 1. And lastly, let's see what happens when x equals negative 2. I get y equals minus a negative 2 minus 4. So y is equal to 2 minus 4, negative 2. So let's sketch this. Place all your tick marks. So at negative 4, 0. Negative 3, we're at negative 1. At negative 2, we're at negative 2. And so it should look like oh boy. Okay. Let's try it again. Not bad. So this is x plus y plus 4 equaling 0. Let me do 51. Three x minus y equals 4. Let's add 4. Add y, subtract 4 from both sides of my equation. So I get here that y is equal to 3x minus 4. So let's pick the following values for x. Well, I guess just 1, 2, 3, because negative 1 gives you 7. Yeah, so 1, 2, 3 is the better. Okay, so let's pick 1, 2, 3. So if x is 1, then y is equal to 3 times 1 minus 4. 3 minus 4 is negative 1. Determine y when x is 2. So y equals 3 times 2 minus 4. 6 minus 4 is 2. And let's pick x, determine y when x is 3. Y equals 3 times 3 minus 4. 9 minus 4 is 5. Okay, so let's sketch the graph. Okay, sketch the graph. Okay, So when x is 1, y is negative 1. When x is 2, y is 2. When x is 3, y is 5. So let's try to place a line through these. And so this is the graph of 3x minus y is equal to 4. Let me do 53. X equals 0. So it doesn't really matter what point you pick. Of course, they can't be too close or too far away. But x is always equal to 0. So the sketch is going to look like x is 0, y is negative 1, 0, 1. And so this, that's kind of going overkill. This is my line. So this is the line of x equaling 0. The y-axis. It's a vertical line. Lastly, then we do problem 55. Y equals 0. So for x, let's just do negative 1, 0, 1. The y values are always 0. Let's sketch the graph of this. So negative 1, 0, 1. Y is always 0. So it's just the x-axis. So this is y equals 0. It is a horizontal line. Okay. So that really finishes off section 3.2. Let me go on. And so I guess I'll, oh, wait. 3.2. Oh, there's still 2 more problems. Let me do problem 57. Four x plus 3y equals 12. Okay. Let's do 0. Okay. Let's do negative 3, 0, 3. So when x is negative 3, I get 4 times negative 3 plus 3y equals 12. So I get a negative 12 plus 3y equals 12. Add 12 to both sides. So 3y equals 24. Divide by 3. So y equals 8. Let x equal 0. So you get 4 times 0 plus 3y. And so I get 3y equal to 12. Divide by 3. And so x is equal to 4. Y is equal to 4. Okay. And lastly, let x equal 3. So I have 4 times 3 plus 3y equals 12. So I have 12 plus 3y equals 12. Subtract 12 from both sides. So 3y equals 0. Divide by 3. So y equals 0. Okay. So let's sketch the graph of this. So negative 3, 8, 4, 5, 6, 7, 8, 0, 4, and 3, 0. Okay. So let's sketch the graph. Try that again. That's a little bit better. Okay. So this is the graph of 4x plus 3y equals 12. And lastly, 59. Five x minus 2y is equal to 10. Intercepts are good for this, actually. So 0, 0. Okay. And then, I guess it doesn't really matter. For x, do 2 more. So let's say 2. Oh, wait, 2 will give you 0. So let's say minus 2. Okay, so let's do that. So I have, let's see what happens when x is 0. So I have 5 times 0 minus 2y equals 10. 5 times 0 is 0, minus 2y is negative 2y. Divide both sides of the equation by negative 2. So y equals negative 5. Let's plug in, determine what x is when y is 0. And so I have 5x minus 2 times 0 equals 10. Well, 2 times 0 is 0. 5x minus 0 is 5x. Divide both sides of the equation by 5. So x is equal to 2. And lastly, let's pick negative 2. Actually, positive 4 would be better because it'll give you a smaller value. Let's pick 4. So when x equals 4, I have 5 times 4 minus 2y equals 10. And so 5 times 4 is 20, minus 2y is 10. Subtract 20 from both sides of my equation. So negative 2y equals negative 10. Divide both sides of the equation by negative 2. So y is equal to positive 5. Okay, so let's sketch the graph. I got to go to 5s. I can do it. Why is it got to be 5? So I have to have 11. Okay, so I'll just do it in halves. Okay, so we're here when x is 0. We're at negative 5. Four, we're at 5. 1, 2, 3, 4. We're at 5. 1, 2, 3, 4, 5. And at 0, we're at 2, we're at 0. Okay, let's sketch the graph. And so it should look something like, try again. Okay, 1 second. Sorry. And this is the sketch of the graph. Oh, good, it went back. Okay. So let's do this. I'm just going to scroll. It's a little hard to graph it. Okay. Good enough. That looks good to me. So this is a sketch of the graph. 5x minus 2y equals 10. And so that finishes off this section. And that's it for today. So I guess we'll see you guys tomorrow.